Hello there, and welcome to The Sleepless Scientist. Tonight, we turn our gaze to the most familiar yet endlessly mysterious companions of the night, the stars. They have burned above us for as long as humanity has walked the earth, filling our skies with wonder, guiding travelers across oceans, inspiring stories, and quietly forging the very elements that allow us to exist. Their light travels across unimaginable distances, carrying messages from billions of years ago, twinkling gently by the time it reaches our eyes. In this journey, we'll drift slowly among the stars, learning how they are born, how they live, and what secrets they hold in their shimmering glow. We'll reflect on the science, the poetry, and the beauty of these ancient lights that have always been with us, steady companions through both the nights of our past and the dreams of our future. And just before we begin, if these calm, curious explorations help you unwind or give you a quiet way to end your day, consider liking and subscribing to the channel. It helps others find their way here too.
You won.
Sleepy soul at a time. Stars, the ancient lights of the universe. At first glance, stars seem eternal, scattered across the sky in patterns that feel unchanged. Yet each point of light is a furnace, burning with immense power, and each has its own story of birth, life, and death. They are ancient in every sense, with some shining long before our sun was even born. When we look upward, we are not only seeing distant suns, we are gazing back in time. For millennia, humans looked at the stars with awe, weaving myths and guidance into their glow. Now, we know that stars are suns, scattered across a vast galaxy of billions, each a source of energy and light, but the wonder remains unchanged. Their flicker in the night sky reminds us of our smallness, but also of our connection to the wider cosmos. The stars are ancient lights, and yet every night they greet us as if for the very first time. How stars are born in stellar nurseries. Let's go back in time to the very beginning of a star's life. Deep within vast clouds of gas and dust, gravity begins to gather matter together. Slowly, the cloud contracts, forming dense knots. As the material piles in, the core grows hotter and denser, until something extraordinary happens. Nuclear fusion begins. A star is born. These regions, called stellar nurseries, often glow faintly, lit by the very stars they create. The Orion Nebula, visible even to the naked eye, is one such nursery, a cradle where countless stars are still forming. It is both a place of chaos and beauty, where gravity sculpts the future light of the universe. To picture it is to imagine clouds of gas stretching for light years, slowly knitting themselves into brilliant suns. Every star in the sky began this way, in a hidden nursery, quietly waiting for its chance to shine. The role of cosmic dust in star formation. Cosmic dust might sound insignificant, but it plays a crucial role in the birth of stars. These tiny particles, often smaller than a grain of sand, fill interstellar clouds. They cool the surrounding gas, allowing gravity to pull material inward more effectively, nurturing the early stages of stellar growth. Though invisible to the eye, dust shapes the universe. It blocks light, creating dark patches in the sky that hide new stars within. It scatters and reflects starlight, giving nebulae their soft, ethereal glow. Without dust, stars would still form, but the universe would look less like the soft tapestry we admire, and more like an exposed, empty grid. The next time you see a hazy patch in the night sky, imagine the dust grains at work, silent architects, shielding and shaping, helping young stars find their light. The colors of stars and what they mean. At first glance, all stars seem white, but look more closely, and you'll notice subtle shades. Some glow with a faint reddish warmth, while others shine with icy blue intensity. The color of a star tells us its temperature. Red stars are cool by cosmic standards, their surfaces around 3,000 degrees Celsius, while blue stars blaze at tens of thousands of degrees, their light sharp and powerful. These colors are more than decoration. They are clues. They reveal the star's mass, age, and life expectancy. A red dwarf, may burn gently for trillions of years, while a massive blue giant lives briefly, burning furiously before collapsing into a spectacular death. Every shade we see is part of a grand story, written in light. The colors remind us that stars are not all the same. They are diverse, varied, and each burns in its own unique way across the endless dark. Why stars twinkle in the night sky? Here's something surprisingly simple. Stars twinkle not because they themselves flicker, but because of the air above us. As starlight travels through Earth's atmosphere, it is bent and distorted by turbulent layers of air. To our eyes, the result is a gentle, shimmering effect, as though the star were dancing. From space, stars shine steadily, their light undisturbed. But from Earth, the twinkle adds a layer of beauty, turning even the smallest pinprick of light into something alive. It's as if the atmosphere has taken the universe's distant lanterns and given them a playful sparkle, one that has comforted and inspired generations of stargazers. The next time you see a twinkling star, know that it is steady and constant in the void, but that our living, breathing atmosphere lends it this gentle, soothing illusion, a reminder that the sky is both a window and a veil. The life cycle of a star explains slowly. Think about this. Every star you see has a life story, just as we do. It begins in the quiet cradle of a nebula, grows into a luminous sun, and eventually meets an end, sometimes gentle, sometimes violent. The path a star takes depends largely on its size. Small stars live long, steady lives, burning their fuel slowly, while massive ones blaze fiercely, destined for a fiery finale. Over billions of years, stars pass through stages. They swell into giants, shrink into dwarfs, or explode as supernovae. In each stage, they give back to the universe, scattering elements, reshaping the cosmos, and seeding the next generation of stars. The life cycle of a star is not rushed. It is measured in timescales so vast, they are difficult to imagine. Billions of years of steady fusion, patiently transforming hydrogen into heavier elements. In their births, their lives, and their deaths, stars are constant reminders of both change and endurance. How small stars live the longest lives. Here's something surprising. In the cosmos, it is often the smallest stars that live the longest. Red dwarfs, faint and unassuming, burn their fuel with great efficiency. Unlike their larger cousins, they do not race through their resources. Instead, they sip at them carefully, stretching their lives into trillions of years, far longer than the current age of the universe itself. Because of their patience, no red dwarf has ever yet reached the end of its life. The universe is not old enough for us to have seen one die. Imagine that, stars born billions of years ago, still shining quietly, with countless more years ahead. Though they are often invisible to the naked eye, red dwarfs make up the vast majority of stars in our galaxy. They are not the brightest, nor the most dramatic, but in their quiet way, they are the survivors of the universe, destined to glow long after other stars fade. Red dwarfs, the most common stars in the galaxy. If you look up at the night sky, you may think the stars you see are a fair sample of what's out there, but in truth, nearly all of them are exceptions. Most stars in our galaxy are red dwarfs, too faint to see without a telescope. These tiny stars are the hidden majority, shaping the fabric of the Milky Way, while rarely revealing themselves to casual stargazers. Red dwarfs are cooler and dimmer than stars like our sun, yet they are abundant, scattered across the galaxy like a quiet background chorus. Many of them are orbited by planets, some within zones where liquid water might exist. Their longevity means that if life ever emerges near them, it would have vast stretches of time to develop. Though we may never see them twinkling overhead, red dwarfs are everywhere, whispering to us that the universe is filled with more than we know, more than we can see. Giant stars that burn bright but die young. Now let's turn to the opposite end of the spectrum. Giant stars, massive and dazzling, are the fireworks of the cosmos. They burn their fuel with furious intensity, their blue-white light flooding space. But this brilliance comes at a cost. These stars live fast, often lasting only a few million years, a blink compared to the billions enjoyed by smaller suns. When their time runs out, they do not fade quietly. Instead, they end in cataclysm, exploding in spectacular supernovae that light up entire galaxies. In their destruction, they give the universe something precious: heavy elements like iron, gold, and uranium, forged in the furnace of their cores and scattered into space. To see a giant star is to glimpse beauty balanced on the edge of impermanence. Their light is a fleeting gift, reminding us that brightness is not always tied to longevity, and that even the briefest lives can shape the universe profoundly. The balance between gravity and fusion. Every star, no matter its size, is engaged in a delicate dance. On one side, gravity pulls inward, trying to collapse the star under its immense weight. On the other, nuclear fusion pushes outward, releasing energy that holds gravity at bay. It is this balance, this quiet tug-of-war, that allows a star to shine steadily. As long as fusion continues, gravity cannot win. The star remains stable, glowing with constant light, but eventually, fuel runs low, and the balance begins to tip. The star may swell, collapse, or explode, depending on its mass. This balance is invisible, yet it is the very reason we exist. Without the steady light of stars, there would be no warmth, no planets capable of life, no elements forged in their cores. The universe itself is shaped by this tension, this cosmic equilibrium that plays out endlessly across the skies. How stars shine for billions of years. At the heart of every star lies its secret fusion. Deep within the core, immense pressure and staggering heat force hydrogen atoms to merge, creating helium. In that process, a tiny portion of mass is converted into pure energy, radiating outward as light and warmth. It's this steady release that allows a star to shine for billions of years, glowing with a patience far beyond anything we can imagine on Earth. The sun, for instance, has already been shining for 4.6 billion years, and it still has billions more ahead. Each day, it burns through unimaginable amounts of fuel, yet its reservoir is vast. Stars seem constant because to us, they are. Their light fills generations, outlasting empires, civilizations, even species. It is humbling to think that the sunlight falling on your skin was created in reactions at the heart of the sun, long before it traveled across space to reach you. Each beam is a quiet gift, born of an ancient process that keeps stars alive and the cosmos aglow. The elements forged inside stars. Here's something extraordinary. Stars are alchemists. Within their blazing cores, they forge the very building blocks of everything around us. Beginning with hydrogen, stars create helium, carbon, oxygen, and heavier elements through fusion. In their later stages, massive stars can even produce iron, but their power has limits. When iron builds up, the star can no longer sustain fusion. The result is collapse, and often a violent explosion. In that death, the star scatters its creations into space, seeding future clouds of gas and dust with the materials needed for planets, and eventually, life. Every atom of carbon in your body, every molecule of oxygen you breathe, every trace of calcium in your bones was once inside a star. We are living proof of stellar work, tiny echoes of ancient furnaces that burned long before our world was born. To say we are stardust is not poetry alone, it is scientific truth. Supernovae, the explosive death of massive stars. When a massive star reaches the end of its life, the result can be one of the most spectacular events in the universe, a supernova. In a single moment, the star collapses, then blasts its outer layers outward with incredible force. For a brief time, it can shine brighter than an entire galaxy. Supernovae are not just spectacles, they are cosmic recyclers. They scatter heavy elements across interstellar space, enriching the galaxy with materials that form new stars, new planets, and even living beings. The iron in our blood and the gold in our jewelry were once forged in such explosions. Ancient observers recorded supernovae as mysterious new stars appearing in the sky, burning fiercely before fading. Today, we understand them as endings, but also as beginnings. In death, stars give back to the universe, ensuring that creation is an endless cycle. In their brilliance, they remind us of both fragility and renewal. Neutron stars, matter crushed beyond imagination. Sometimes, after a supernova, what remains is a neutron star, a remnant so dense it defies comprehension. Imagine compressing the mass of our sun into a sphere only a dozen miles wide. Inside, atoms collapse, electrons and protons merging into neutrons, creating matter so tightly packed that a teaspoon of it would outweigh a mountain. Neutron stars spin rapidly, some turning hundreds of times per second. Their magnetic fields are intense, their surfaces strange and exotic. They are among the most extreme objects we can study, balancing on the edge of what physics can explain. Despite their violence and density, neutron stars are astonishingly beautiful in their mystery. They are reminders of what the universe can create when it pushes matter to its very limits, showing us the strange and wondrous outcomes of stellar death. Pulsars, stars that beat like cosmic hearts. From some neutron stars comes a rhythm, a steady pulse of light or radio waves sweeping through space. These are pulsars, cosmic lighthouses, spinning so quickly that their beams flicker across the galaxy like beacons. To early astronomers, they seemed so regular that some wondered if they were signals from other civilizations. The pulses are not messages, but the byproducts of physics, created by jets of radiation aligned with the star's rotation. Yet their regularity makes them useful. Pulsars can be cosmic clocks, their precision rivaling the best instruments on Earth. There is something poetic in their beat. Each pulse is the echo of a star that once burned brightly, now transformed into a remnant that still sends its voice across space. To listen to a pulsar is to hear the afterlife of a star, steady and unyielding, like the slow heartbeat of the cosmos itself. Black holes, born from collapsing stars. When the most massive stars run out of fuel, even the violence of a supernova is not enough to halt their collapse. Gravity takes over completely, crushing the star into a point so dense that not even light can escape. This is the birth of a black hole. Black holes are among the most mysterious objects in the universe. They bend space and time around them, creating an event horizon, a boundary beyond which nothing can return. From the outside, they appear invisible, revealed only by the effects they have on nearby stars and gas. It may seem like an ending, but black holes are part of the cosmic cycle. They can influence entire galaxies, their gravity shaping the movement of stars, their energy powering jets of radiation that stretch for light years. Out of collapse comes influence. Out of silence comes power. A black hole is the universe whispering its deepest secrets, where the laws of physics blur into the unknown, the mystery of magnetars and their power. Think of a neutron star, already one of the densest objects in existence. Now imagine one with a magnetic field 1,000,000,000 times stronger than Earth's. That is a magnetar, an exotic remnant whose power defies comprehension. Magnetars are rare, yet their influence is immense. Their magnetic fields can twist and snap, releasing bursts of energy so powerful they can be detected across galaxies. On occasion, these outbursts send flares brighter than anything else in the sky, brief flashes that remind us how extreme the cosmos can be. Despite their violence, magnetars are also fragile. Their power comes from instability, and over time their fields weaken, leaving behind quieter neutron stars. For now, though, they remain some of the strangest actors in the stellar story. Cosmic furnaces turned magnetic titans, their very existence pushing the boundaries of what we understand about matter and energy. Binary star systems, two suns dancing together. Not all stars live alone. In fact, many exist in pairs, orbiting one another in a cosmic dance that can last for billions of years. These are binary star systems, and their relationships shape the fates of both suns. Some orbit closely, exchanging matter in dramatic flows that create bursts of light. Others circle each other from afar, their gravity a gentle tether that keeps them bound across immense distances. To worlds within such systems, the sky might hold not one sunrise but two, their light mingling in hues of gold and red. Binary stars remind us that even in the vastness of space, companionship is common. Their dance is one of balance, gravity, holding them together, motion, keeping them apart. It is a quiet metaphor, written in starlight, for the delicate bonds that endure even in the cold reaches of the cosmos. Triple star systems and beyond. Here's something wondrous. Some stars live not in pairs, but in families. Triple systems, or even more complex groups, exist throughout the galaxy. In these systems, stars orbit in intricate patterns, weaving paths that seem almost choreographed. For any planet caught within such a system, the skies would be a shifting canvas. 3 suns rising and setting, casting strange shadows, bathing landscapes in shifting tones of light. The rhythm of day and night would be unpredictable, yet breathtaking. Astronomers study these systems to understand gravity's subtle effects, but they also spark the imagination. They remind us that nature's creativity extends far beyond what we see from Earth. Our single sun feels steady and familiar, yet elsewhere in the galaxy, stars share their lives in groups, families bound by gravity, each with a story of connection and motion. Stars that wander alone through space. Not all stars find companions or remain bound to galaxies. Some wander alone, ejected from their birthplaces by gravitational encounters or violent explosions. These rogue stars drift through interstellar space, carrying their light into the dark, solitary travelers on journeys with no end. It is a haunting thought. A star complete with its planets, if any survive, moving silently through the void, untethered to the sweeping arms of a galaxy. These stars are rare, but they exist, reminders that not all stories are bound by place. To imagine such a star is to imagine true solitude, yet even alone, it shines. Its light spreads into the emptiness, a beacon without an audience. There is quiet beauty in that persistence. A lone traveler carrying on, bright against the dark, a solitary flame in the endless night. Rogue stars escaping their galaxies. Every so often, a star is hurled from its home with such violence that it escapes the pull of its galaxy altogether. These are rogue stars, exiles cast adrift into the intergalactic void. The causes vary. Perhaps the star passed too close to a supermassive black hole, or perhaps it was flung outward by the chaotic gravity of colliding systems. Whatever the reason, its fate is to drift alone between galaxies, where the night is darker than anywhere else. For billions of years, these stars shine in solitude, carrying with them the chemical fingerprints of their origins. If any planets orbit such a wanderer, they too are exiled, their skies stripped of familiar constellations, left with only their solitary sun. Rogue stars are reminders of how violent the universe can be, but also how enduring. Even far from home, they shine, carrying a piece of their galaxy into the deepest reaches of space. Hypervelocity, stars and their strange journeys. Even rarer than rogue stars are hypervelocity stars, objects so fast that they race through the galaxy at millions of kilometers per hour. Most are thought to be launched by encounters with black holes, which can fling them outward with extraordinary speed. Imagine a star, once nestled comfortably within a galactic arm, suddenly accelerated so fiercely that it becomes a projectile, streaking toward intergalactic space. To observers from afar, it would appear as a lone spark, racing endlessly into darkness. These journeys stretch beyond human imagination. A hypervelocity star might one day leave its galaxy behind entirely, becoming a true intergalactic traveler. In their speed, there is a sense of both violence and freedom. They embody the extremes of motion, showing us how gravity, normally the force that binds, can also release with astonishing force. Star clusters, families of stars bound together. While some stars wander alone, many are born into clusters, families bound by gravity and shared origin. Star clusters come in different kinds, but all represent the bonds that form when great clouds of gas collapse and fragment into countless suns. In a young cluster, stars crowd together, their light blending into luminous gatherings, visible even across vast distances. To stand near such a cluster would be to witness a sky ablaze, filled with stars brighter and closer than any we see from Earth. Over time, some stars drift away, but many remain tethered, companions for billions of years. Star clusters remind us of beginnings. They are the nurseries grown older, where siblings remain in close embrace, carrying within their orbits the story of their shared birth. In their light we glimpse the truth that even in the cold silence of space, families endure. Globular clusters older than the galaxy itself. Far out in the halo of the Milky Way lie ancient spheres of stars, globular clusters. These tightly packed gatherings can hold hundreds of thousands, even millions of suns, bound together in a glittering ball of light. They are among the oldest known structures in the universe, older even than our galaxy, relics from the early days after the Big Bang. In these clusters, stars shine with a steady glow, many of them small, red, and enduring. Their sheer age gives us a window into the history of the cosmos, letting us study what conditions were like billions of years ago. Looking at a globular cluster is like peering back into time, seeing a chapter of the universe that has persisted while galaxies formed, collided, and evolved around it. These are the elder statesmen of the stellar world, quiet witnesses to nearly the entire history of the cosmos. Open clusters, young stars, growing together. If globular clusters are the ancient ones, open clusters are the youthful gatherings, found mostly in the spiral arms of galaxies. These groups contain dozens or hundreds of young stars, born together from the same cloud. Their bonds are looser, their lives shorter, but their brilliance is striking. Many of the most famous constellations contain open clusters, such as the Pleiades and Taurus. To the naked eye, they appear as delicate gatherings of light, but through telescopes, they reveal themselves as vibrant families of blue, hot, newly born stars. Over time, the gravity that holds them weakens, and the stars drift apart into the broader galaxy. Yet for millions of years, they shine together, their shared light a reminder of their common origin. Open clusters are the cosmic youth, bright, energetic, and fleeting, but no less wondrous for their impermanence. The brightest star in our sky, Sirius. Among all the stars visible to the naked eye, Sirius reigns supreme as the brightest. Known as the Dog Star, it lies in the constellation Canis Major, shining so powerfully that it has inspired mythologies across cultures. Its brilliance comes not only from its intrinsic luminosity, but also from its closeness to us, just over 8 light-years away. Sirius is not a single star, but a binary system, composed of Sirius A, a dazzling white main sequence star, and Sirius B, a faint white dwarf, the remnant of a star that long ago burned through its fuel. To ancient peoples, Sirius rising in the dawn sky marked the seasons, guiding planting, harvests, and rituals. Even today, its brightness has a way of capturing the eye, drawing us upward. When you look at Sirius, you are seeing light that has traveled across space for years to reach you, light that once bathed planets, if any existed there, in warmth and glow. Its constancy is a comfort, a reminder of how the stars serve as anchors in the shifting seas of the night. The fate of our sun billions of years from now, it is natural to wonder about the future of our own star, the sun. For now, it is steady and dependable, a yellow star that has burned for nearly 5 billion years. But like all stars, it has a life cycle. In another 5 billion years, it will exhaust its hydrogen fuel. When that day comes, the sun will swell into a red giant, expanding far beyond its current size. It may engulf Mercury and Venus, and perhaps even Earth, transforming the solar system in ways we can scarcely imagine. Eventually, it will shed its outer layers, creating a glowing planetary nebula, while its core shrinks into a white dwarf, glowing faintly for trillions of years before fading away. Though this distant future might seem unsettling, it is also deeply humbling. The sun, which now nurtures life on Earth, will one day become part of the endless cycle of matter and light that defines the universe. Its end is not destruction, but transformation, a reminder that stars, too, are subject to time's patient hand. Why the sun is just an average star. From our vantage point on Earth, the sun dominates the sky. It seems immense, overwhelming, the very center of existence. Yet, in the wider cosmos, our sun is unremarkable. It is a G-type main sequence star, one among billions, quietly burning hydrogen into helium. There are stars far larger, burning with a fiercer light, and others much smaller, glowing faintly in the dark. The sun is not the biggest, brightest, or oldest. It sits comfortably in the middle, a star of moderation and stability, and in that ordinariness lies its gift. Because the sun is steady, it provides Earth with the consistent warmth and light needed for life. Because it is not prone to violent extremes, it has given our planet billions of years to evolve oceans, forests, and thinking beings who can look back at it with gratitude. The sun's averageness is part of its beauty. It reminds us that the extraordinary can arise not from the extremes, but from the gentle and the steady. It is a star that has given us time, and in that time, we have found meaning, solar flares, and the power of stellar storms. Yet even the calm sun has tempests hidden in its heart. Every so often, its magnetic fields twist and snap, unleashing immense bursts of energy called solar flares. These are storms on a scale beyond comprehension, flinging radiation across the solar system in seconds. When directed toward Earth, solar flares can disrupt satellites, communication networks, and power grids. But they also create beauty, igniting auroras that ripple across polar skies in curtains of green and red. To watch an aurora dance is to glimpse the sun's restless heartbeat, felt across millions of kilometers. These storms remind us that stars are not serene lamps, but dynamic, living furnaces. They seethe with energy, their surfaces in constant motion. And while solar flares may pose challenges for our technology, they also remind us of the vast, uncontrollable forces that shape our existence. Even in its storms, the sun is a provider. Without its magnetic fields and occasional flares, Earth would not have the shield of its magnetosphere or the beautiful auroras that paint the night. There is a fierce poetry in these tempests, a reminder of the sun's raw power, sunspots, and their strange cycles. Look closely at the surface of the sun, and you will find dark patches scattered across its glowing face. These are sunspots, cooler regions created by tangled magnetic fields. They may seem small, but many are larger than Earth itself, vast blemishes on the otherwise brilliant star. Sunspots follow cycles, appearing and fading in patterns roughly every 11 years. At times of solar maximum, the sun's surface can be peppered with them, accompanied by flares and storms. At solar minimum, the sun grows quieter, its surface calmer. These cycles have fascinated astronomers for centuries, linking the rhythms of the sun with the rhythms of life on Earth. Farmers once watched them to predict weather patterns. Sailors noted their presence in navigation logs. Today, scientists study them to understand how solar activity influences our planet's climate and technological systems. There is something calming in their predictability. Though the sun rages and flares, it also follows patterns as steady as a heartbeat. Sunspots are the punctuation marks of its story, reminders that even in its fiery brilliance, it has cycles, moods, and seasons of its own. How stars control the habits of planets. Think about this. Every planet, every moon, and every world is a reflection of the star it orbits. Stars are not only creators of light, they are caretakers of planetary systems. Their gravity shapes orbits, their warmth sets climates, and their winds sculpt atmospheres. On Earth, the sun dictates the rhythm of days and seasons. Its steady glow allows water to remain liquid and life to flourish. But around other stars, the story shifts. Some worlds orbit too closely, locked in perpetual heat, while others lie so far away that ice dominates their landscapes. The habitable zone is a delicate balance, defined by the energy a star pours outward. Even storms on stars can ripple across planets, stripping atmospheres or stirring magnetic fields. Without stars, planets would drift cold and lifeless in the dark. With them, worlds become diverse canvases, oceans, deserts, mountains, and perhaps life itself. Stars are both rulers and nurturers. They decide whether planets are barren or fertile, harsh or welcoming. And in this dance of light and gravity, we begin to see how deeply our fate, and the fate of any other life beyond, is bound to the stars. The influence of stars on potential life. Life, wherever it may arise, depends on its star, the chemistry of water, the growth of plants, even the chance for civilizations to emerge. All are written by the star's steady or unsteady glow. A gentle star, like our sun, offers a long window for life to grow. A volatile star might shorten that window, bathing its worlds in radiation that both hinders and drives evolution. Some stars emit far more ultraviolet light than ours, challenging organisms to shield themselves. Others are so faint that life might adapt to perpetual twilight under skies of dim red. The diversity of stars suggests the diversity of possible life forms, each adapted to its own cosmic hearth. Astronomers often wonder, what would beings around another star see when they look up? Would they worship their sun as humans once did? Would they track its storms, its cycles, its moods? Stars are not only physical guardians but also symbols, shaping the imaginations of those who look toward them. It is humbling to realize that in the search for life, we are also searching for stars that mirror, in their own way, the gentle steadiness of our own. The closest star beyond the Sun, Proxima Centauri. Just over 4 light-years away lies Proxima Centauri, the nearest star to our solar system. Though it is our closest neighbor, it is far too faint to be seen with the naked eye. A red dwarf, Proxima, is much smaller and cooler than our Sun, glowing dimly in the constellation Centaurus. Proxima Centauri has planets of its own, including one that orbits in its habitable zone. Astronomers call it Proxima b, a world that may have liquid water under the right conditions. The thought is staggering. The nearest star to us holds a planet that could, in theory, cradle life. Yet red dwarfs, like Proxima, are unpredictable. They flare with bursts of radiation that may strip atmospheres from their planets, making life difficult to sustain. Still, in the quiet moments between flares, one can imagine oceans reflecting a red sun, or skies glowing dimly with a constant twilight. Proxima Centauri reminds us that even our cosmic neighborhood is filled with mysteries. The closest star has already given us a possible world, and beyond it lie countless more, waiting to be discovered. Alpha Centauri, a star system next door, not far from Proxima, lies the Alpha Centauri system, a trio of stars bound together in a cosmic dance. Alpha Centauri, A and B, are both sun-like stars, orbiting each other in a slow embrace, while Proxima drifts farther out, a faint companion on the edge. For centuries, dreamers have looked to Alpha Centauri as the first destination for interstellar travel. Its twin stars shine brightly in southern skies, and their similarity to the Sun stirs hope that planets around them might resemble our own. Indeed, astronomers have found hints of worlds there, though none confirmed to be Earth-like just yet. What makes Alpha Centauri so captivating is its familiarity. Unlike distant giants or faint dwarfs, these stars feel like kin, bright, steady, and inviting. They remind us that our Sun is not unique, but part of a larger family scattered through the galaxy. If humanity ever leaves its home star, Alpha Centauri may well be the first harbor we reach. It is a nearby lighthouse in the endless ocean of the cosmos, calling softly to the ships we have yet to build. The myth and wonder of Betelgeuse. High in the constellation Orion lies Betelgeuse, a red supergiant nearing the end of its life. It glows with a ruddy light, visible even to the naked eye, marking the shoulder of the great hunter in the night sky. Betelgeuse is vast, so vast that if it were placed in the center of our solar system, it would extend past the orbit of Jupiter. Its surface boils and pulses, shedding gas and dust into space as it prepares for its final act, a supernova. Across cultures, Betelgeuse has inspired myth and wonder. Its shifting brightness, which sometimes dims and sometimes flares, has led many to speculate about its fate. One day, it will explode in a brilliant burst, outshining even the moon for weeks before fading. That explosion will scatter heavy elements into space, seeding future stars and planets with the raw material for life. Watching Betelgeuse is like watching a candle flicker at the end of its wax. There is beauty in its impermanence, a reminder that even the mightiest stars must bow to time. And in that final bow, they give the universe gifts that endure long after their light is gone. Rigel, a blue giant burning fiercely. Across from Betelgeuse, in Orion's frame, lies Rigel, a brilliant blue supergiant star. Where Betelgeuse glows red with age, Rigel burns blue-white, young and ferociously bright. It is one of the most luminous stars visible from Earth, radiating tens of thousands of times more energy than our Sun. Rigel's light is not merely bright, but piercing. Blue stars like it are incredibly hot, their surfaces seething at temperatures that make red and yellow stars appear tame. Yet with that intensity comes brevity. Rigel, like all blue giants, will live only a few million years before exhausting its fuel and collapsing into a violent end. When you gaze at Rigel, you are seeing a star in its prime, shining with all the brilliance of youth. But in cosmic time, it is a fleeting spark that makes its light all the more precious, a reminder that even the brightest fires burn quickly. Rigel's brilliance has guided travelers for centuries, yet its true story is one of impermanence. It tells us that the universe values variety. Some stars live long and steady lives, others blaze briefly, leaving behind echoes that ripple across the cosmos. Vega and the Summer Triangle. In the quiet skies of summer, Vega shines as one of the brightest stars overhead. Part of the constellation Lyra, it anchors an asterism known as the Summer Triangle, along with Deneb and Altair. Together, these stars form a celestial landmark, visible across the world. Vega has long held human fascination. In ancient times, it was considered the pole star, the point around which the heavens seem to turn. Today, it remains one of the most studied stars, a nearby beacon just 25 light-years away. Its brilliance hides a secret. Vega rotates rapidly, spinning so fast that it bulges at its equator. This rapid rotation distorts its shape, showing us that even the calmest lights in the sky can harbor hidden dynamism. Around Vega lies a disk of dust and debris, hinting at planets in the process of formation. For storytellers, Vega is often paired with Altair in tales of lovers separated by the Milky Way. For scientists, it is a window into stellar physics. And for dreamers, it is a jewel of summer nights, shining gently on those who pause to look upward. Polaris, the North Star guiding travelers. For millennia, wanderers have looked to Polaris, the North Star, to guide their journeys. It sits almost directly above Earth's northern axis, appearing fixed in the sky, while all other stars seem to circle around it. This stillness has made it a compass of the heavens, a beacon for travelers across oceans and deserts. Polaris itself is not a solitary star, but a system with a supergiant at its heart, accompanied by smaller companions. Its light is steady but complex, a symbol of guidance that is richer than it first appears. What makes Polaris so calming is not only its position, but its symbolism. In a changing world, it stands unmoved, offering direction when paths seem uncertain. It reminds us that in the vast and shifting universe, there are anchors we can hold on to. Though the North Star will not always remain in this position, cosmic cycles will one day shift Earth's axis. It has served as humanity's compass for thousands of years. To look at Polaris is to share a connection with countless ancestors who also raise their eyes to the same point of light, trusting it to carry them safely home. Stars used in ancient navigation. Long before compasses, maps, or satellites, The stars were humanity's first navigators. Sailors traced their paths across oceans by watching constellations rise and set. Desert travelers steered their caravans at night by learning which stars clung low to the horizon. The stars became a language of survival, written in light. The Southern Cross guided those below the equator, while Polaris served as the northern anchor. The patterns of Orion, Cassiopeia, and the Pleiades told time, marked seasons, and showed direction. To those who relied on them, the stars were both maps and companions. Even today, in the glow of cities where many stars are hidden, their legacy endures. Navigation satellites orbit above us, but they are named and shaped by the traditions of stellar guidance. The stars remind us of a time when the world felt boundless, and the only way forward was to trust the lights above. There is a deep poetry in this connection. The stars do not speak, yet they have guided countless footsteps and sails. They are silent teachers, always present, waiting for us to notice. The stories humans tell about the stars. Beyond their physical brilliance, stars have always been storytellers. Across cultures, humans have drawn patterns in the night sky, weaving constellations from scattered points of light. These stories vary, but they reveal a shared impulse to find meaning in the vastness. In Greek mythology, Orion hunts forever across the sky. In Chinese tales, Vega and Altair are lovers separated by the Milky Way, reunited once a year by a bridge of magpies. The Navajo see constellations as guardians and guides, shaping their understanding of the world. Each story is a reflection of the culture that created it, yet all point to the same truth. Stars are more than physics. They are mirrors of human imagination. By telling stories about them, we weave ourselves into the cosmos, binding our small lives to the eternal sky. Tonight, when you look at the stars, remember you are also gazing at stories told for thousands of years. The same constellations that guided shepherds, kings, and wanderers still shine above us, and perhaps, in their quiet way, the stars are telling us that we too are part of their story. Constellations and the patterns we see. At first glance, the night sky may seem like a random scattering of stars, yet humans have always sought patterns, connecting the dots across the vast darkness. These connections form constellations, stories written in light. Constellations vary by culture and hemisphere. Orion, Cassiopeia, and Ursa Major are familiar to many in the northern skies, while the Southern Cross guides travelers below the equator. These patterns are not only poetic, they were practical. Sailors navigated by them, farmers predicted seasons, and time itself was measured by their rising and setting. In a way, constellations are a bridge between science and imagination. Modern astronomy studies the stars' positions and motions with precise measurements, yet the human urge to weave narratives remains unchanged. When you look up and trace a familiar pattern, you are engaging in a ritual as old as civilization itself. The night sky reminds us that order can emerge from apparent chaos, that we have always sought to make sense of our place in the universe. Constellations are maps, calendars, and stories, gently guiding our eyes and our minds toward the infinite. The zodiac stars through history. The zodiac, a ring of constellations along the sun's apparent path, has fascinated humans for millennia. Ancient civilizations used it to track time, predict seasons, and interpret the heavens. Though modern science separates astronomy from astrology, the stars themselves remain unchanged, distant suns tracing slow arcs across the sky. Each zodiac constellation carries its own story, myth, and symbolism. From Aries the ram to Pisces the fish, these celestial markers have been woven into calendars, rituals, and navigation. The ancients looked to these stars to understand the cycles of life, to find rhythm in an unpredictable world. Beyond mythology, the zodiac stars reveal truths about the cosmos. Their positions, brightness, and motion inform us about stellar distances, ages, and compositions. Observing them connects us with the same sky seen by people thousands of years ago, a cosmic thread linking past, present, and future. The zodiac reminds us that the universe is a tapestry of light and time, and that human curiosity has always sought to trace the threads connecting the heavens to life on Earth. Stars seen from the southern hemisphere. Look southward and an entirely different sky emerges. The southern hemisphere offers constellations unseen by most of the northern world, the Southern Cross, Centaurus, and Carina, among others. These stars tell stories of explorers, navigators, and indigenous peoples who read the southern sky with practiced eyes. The Milky Way stretches differently across southern skies, its dense star fields revealing the galaxy's spiral arms with astonishing clarity. Observers in Chile, South Africa, or Australia are treated to panoramas of starlight largely hidden from northern eyes. For humanity, these stars provided guidance, inspiration, and a sense of orientation. Indigenous Australians, for example, embedded knowledge of seasons, hunting, and water sources within the stars, showing how celestial observation could sustain life. To gaze at the southern sky is to be reminded that the universe has perspectives beyond our habitual view. Each hemisphere holds wonders unique to its vantage, and the stars, silent yet brilliant, whisper secrets only visible from certain corners of the world. The oldest stars ever discovered. Some stars are ancient, relics from a time shortly after the Big Bang. These old stars, often found in the galactic halo, are poor in heavy elements, reflecting the universe's primordial chemistry. They have burned steadily for billions of years, outliving many galaxies' youthful structures. Observing these ancient suns is like peering into history itself. Their light has traveled across eons, carrying information about the conditions of the early universe. Each photon tells a story of formation, survival, and resilience against cosmic change. These stars are faint, often invisible to the naked eye, yet their presence is profound. They are reminders that the universe has memory, that even amidst constant motion and transformation, echoes of its earliest days remain. By studying them, astronomers uncover clues about how galaxies formed, how elements were created, and how cosmic evolution progressed. They are living fossils, guardians of the universe's earliest secrets, whispering the story of time itself. Metal-poor stars from the early universe. Among the oldest stars, metal-poor stars are particularly intriguing. Metals in astronomy refer to elements heavier than helium, and the earliest stars formed before such elements were abundant. These stars are primarily hydrogen and helium, offering a window into the universe's infancy. Metal-poor stars illuminate questions about cosmic evolution. How did the first stars form? How were elements synthesized and distributed across galaxies? Their composition tells us that they were born before supernovae had seeded the cosmos with heavier atoms. Despite their simplicity, these stars endure. They shine with quiet constancy, surviving where others have burned out. Observing them is an exercise in patience and wonder, as astronomers parse faint light to reconstruct events from billions of years ago. These stars remind us of humility. The universe is ancient and vast, and the light reaching us carries truths older than our planet, our species, and even our galaxy. In their quiet glow, we see the deep continuity of cosmic history, a chain of existence linking past to present. Population 3 stars that may no longer exist. Let's go back in time to the universe's earliest days, when the first stars flickered into existence. These were the population 3 stars, composed almost entirely of hydrogen and helium, untainted by heavier elements. They were giants, burning fiercely and living briefly, leaving behind the first heavy elements in their explosive deaths. None of these primordial stars are believed to survive today. Their existence is inferred from the chemical fingerprints left in subsequent generations of stars. By studying these traces, astronomers piece together a story of cosmic infancy, a universe awakening, learning to shine, and seeding itself with the raw materials for planets, galaxies, and eventually life. Population 3 stars were the universe's pioneers. Their light illuminated the darkness, igniting the processes that would build the cosmos as we know it. Though we can no longer see them directly, Their echoes resonate in every star that followed, a silent testament to the birth of stellar generations. There is poetry in their absence. The first lights have gone, yet their legacy endures, written in the chemistry of the universe and in the very atoms that make us who we are. How stars created the first elements. After the Big Bang, the universe was simple, primarily hydrogen and helium, with traces of lithium. Heavier elements, those that compose planets, oceans, and life, did not yet exist. Stars in their fiery cores became cosmic alchemists, forging the elements of complexity through nuclear fusion. Hydrogen fused into helium, helium into carbon, carbon into oxygen, and onward through a chain of reactions that built the periodic table's heavier atoms. When massive stars died in supernovae, they scattered these elements into space, enriching the interstellar medium for new generations of stars and planets. This process is the foundation of everything we see and are. Every atom of iron in our blood, every calcium molecule in our bones, every oxygen atom we breathe, was once forged in a star's heart. In essence, stars made the universe habitable. Contemplating this truth evokes a quiet wonder. The stars are more than distant lights. They are the origin of matter itself, the silent factories of existence. Each sunrise is a reflection of their ancient work, a reminder that we are born of stardust. The Milky Way's billions of stars. When we look up on a clear night, the stars appear countless, but even this view is limited. Our galaxy, the Milky Way, contains over 400 billion stars, each with its own story. They populate spiral arms, cluster in ancient halos, and trace orbits that span tens of thousands of light years. These stars vary in size, color, and life cycle. Red dwarfs outnumber all others, burning quietly for trillions of years, while rare blue giants blaze briefly with intense energy. Supergiants shine like celestial lanterns, and white dwarfs mark the remnants of long-dead suns. The sheer scale of this stellar population is humbling. Each star is a sun to potential planets, a nucleus around which worlds could orbit. And yet, despite their multitude, the vastness of the Milky Way allows space for mystery. Stars drift apart, bound by gravity, yet separated by light years, each a small beacon in a galaxy of infinite depth. In considering the Milky Way's stars, we are reminded of both abundance and solitude. Countless suns illuminate the galaxy, yet each one's light carries a unique story across the cosmic night. Why most stars are never seen with the naked eye. Although billions of stars surround us, only a fraction are visible without a telescope. Distance, brightness, and interstellar dust obscure the majority, hiding them from casual observation. The night sky, even at its darkest, is merely a window into a tiny portion of the Milky Way's brilliance. The stars we see are typically nearby or exceptionally luminous. Fainter red dwarfs, the most common type of star, remain invisible, their glow too weak to reach our eyes across the void. Even clusters and nebulae, awe-inspiring through telescopes, often appear as faint smudges to the naked observer. This limitation fosters a quiet humility. The universe is vastly richer than our senses allow us to perceive. Yet modern instruments reveal these hidden stars, letting us explore their numbers, lifespans, and compositions. The unseen majority reminds us that wonder is not constrained by what we can immediately observe. In every dark sky, behind every visible star, there exists a hidden multitude, silent, ancient, and eternal. They await discovery, their light a promise that the universe always has more to teach us, beyond what our eyes can grasp. Infrared astronomy, revealing hidden stars. While many stars remain invisible to the naked eye, infrared astronomy allows us to uncover them. Infrared light passes through interstellar dust that blocks visible wavelengths, revealing stars and structures otherwise hidden. In this light, stellar nurseries glow, young stars emerge from their birth clouds, and the Milky Way's spiral arms are traced with clarity. Infrared telescopes, both on Earth and in space, have transformed our understanding of the galaxy. They uncover clusters, that are otherwise invisible, detect brown dwarfs too faint to see, and map the hidden distribution of stars in distant galaxies. Each discovery adds depth to our picture of the cosmos, showing us that even what seems empty may be full of life-giving light. There is something meditative about infrared astronomy. It reminds us that the universe often hides its treasures, yet with patience and technology, secrets are revealed. Each hidden star uncovered feels like a small victory, a new point of light in the vast tapestry of the Milky Way. Infrared light teaches a quiet lesson that unseen wonders surround us always, waiting for the curious, patient, and attentive to discover them. How we detect stars far beyond sight. At first glance, the universe seems confined to what our eyes can see, but telescopes reveal an astonishing truth. Stars stretch across unimaginable distances, many billions of light years away. Through the subtle clues of light, astronomers can detect these distant suns, observing photons that have traveled for eons to reach us. Different wavelengths, infrared, ultraviolet, X-ray, reveal diverse aspects of stars. Some distant stars are invisible light, but shine brightly in other parts of the spectrum. Spectroscopy allows us to analyze the composition, temperature, and motion of these remote suns, unlocking secrets that would otherwise remain forever hidden. Detecting faraway stars is a lesson in patience. Their faint light, often mingled with the glow of galaxies, or obscured by cosmic dust, demands careful observation and powerful instruments. Yet with every detection, we glimpse a universe far larger than our imagination, a cosmos populated by stars we will never see without help. Through this work, we are reminded of both the vastness of space and the ingenuity of human curiosity. The night sky, once limited to what the eye could perceive, expands endlessly through science and wonder. Stars orbiting supermassive black holes, deep within the hearts of galaxies, including our own Milky Way, reside supermassive black holes, enigmatic objects, millions of times the mass of the Sun. Around these giants, stars orbit with astonishing speed, tracing paths warped by the black hole's immense gravity. Observing these stars reveals both the power and subtlety of gravity. Their movements confirm the presence of the invisible mass at the galactic center, allowing astronomers to map a region that otherwise cannot be seen. The stars themselves become cosmic probes, responding to forces that bend space and time. In our own galaxy, stars like Cez 2 make tight orbits around Sagittarius A*, the central black hole, providing insight into phenomena that challenge our understanding of physics. Their paths are intricate, elegant, and a reminder that even in extreme conditions, patterns and order persist. Watching stars dance around such invisible giants is humbling. It reveals that the universe holds both the delicate and the extreme, and that even in the most violent corners of space, stars continue to shine, orbit, and tell their silent stories. The stars at the edge of the galaxy venture toward the Milky Way's edge, and the density of stars thins. Here, in the galactic outskirts, stars drift slowly, less bound by the gravitational pull of the core. Many are ancient, relics of the galaxy's early formation, orbiting quietly in the halo or outer disk. These stars carry subtle clues about the Milky Way's history. Their motion can reveal past mergers with smaller galaxies, while their chemical composition hints at environments long gone. Each faint point of light is a messenger from a time when the galaxy was young, wandering in solitude at the fringes of the spiral arms. At the galactic edge, the stars remind us of distance and perspective. They shine far from the bustling activity of the core, yet their existence is essential for understanding the Milky Way as a whole. Even in isolation, stars hold meaning, preserving the memory of cosmic events that shaped our home galaxy. The edge of the galaxy is a place of quiet reflection, where stars illuminate both space and time, stretching our understanding of what it means to belong in the universe. the halo of ancient stars around the Milky Way. Surrounding the Milky Way is a vast halo of ancient stars, a ghostly population that encircles the galactic disk. These stars are typically metal-poor, formed during the earliest epochs of galactic assembly. Their faint light contrasts with the bright stars of the spiral arms, yet they provide critical insight into the Milky Way's evolution. The halo stars move in elongated, sometimes erratic orbits, evidence of past mergers with dwarf galaxies and cosmic encounters. They are a living archive, preserving the galaxy's formative events in their motion, chemistry, and distribution. Each halo star is a time capsule, carrying whispers of epochs when the universe was simpler and more volatile. Looking at the halo is like seeing the Milky Way's skeleton, the structure that holds the luminous arms together. It is a reminder that the galaxy is layered, with stories hidden in its outskirts, waiting for patient observers to decode. These ancient stars teach us patience and reverence. Though faint and distant, their collective presence reveals a history billions of years old, connecting us to the earliest chapters of our cosmic home. Stars in neighboring galaxies, beyond the Milky Way, lie countless other galaxies, each with billions of stars. In the Andromeda Galaxy, Triangulum, and countless dwarf galaxies, stars form, live, and die in familiar ways, yet under conditions that may differ subtly from our own. Observing them offers a comparative lens, allowing us to understand stellar life across the universe. Even with powerful telescopes, most stars in other galaxies appear as faint points or blended light. Yet by analyzing their color, brightness, and distribution, astronomers can infer age, composition, and the history of star formation. Through this, neighboring galaxies become laboratories for cosmic evolution, revealing both the diversity and the universality of stellar processes. Watching stars in distant galaxies evokes a meditative perspective. Their light has traveled millions of years to reach us, carrying stories from across space and time. Each one reminds us that our sun, our solar system, and even our galaxy are part of a larger interconnected cosmic tapestry. In the quiet of observation, we can imagine the countless suns shining in those distant islands, each nurturing worlds we may never see, yet whose existence whispers of the vast potential of the universe. Andromeda's billions of suns. At first glance, Andromeda seems like a faint smudge in the night sky, but within it lies a staggering multitude, over 1 trillion stars, shining across its sprawling spiral arms. It is the nearest spiral galaxy to our Milky Way, yet it exists as a world apart, each sun a distant beacon of life and light. Andromeda's stars vary widely, from cool red dwarfs, quietly burning for trillions of years, to massive blue giants that live fast and die young. Its central core glows with concentrated brilliance, dominated by a supermassive black hole, around which countless stars orbit in a cosmic dance. As we observe Andromeda, we are looking not just across space but back in time. The light reaching Earth tonight left those stars over 2 million years ago, before humans walked the planet. In that sense, Andromeda's glow is a time machine, linking us to a distant past and reminding us of the universe's vast temporal and spatial scales. Thinking of Andromeda's billions of suns invites a quiet reflection. Our own galaxy is only one of countless cosmic neighborhoods, each filled with the familiar yet entirely alien light of distant stars. Distant stars we see from billions of years ago. Every star we observe in the night sky carries a story of light, traveling across unfathomable distances. Some of the faintest stars in distant galaxies emit photons that have journeyed billions of years before reaching Earth, a serene bridge between our present and the universe's deep past. This light allows astronomers to peer into epochs when the cosmos was young, galaxies were forming, and the first heavy elements were just beginning to circulate. Observing these stars is like reading a diary written in photons, each one a record of temperature, chemical composition, and motion from times before humans existed. The mind expands with this perspective. To look at a distant star is to see the universe as it once was, a reminder that time and space are intertwined, and that every observation is also an act of historical archaeology. In the quiet hours, one can imagine standing beneath the night sky, feeling the connection to these ancient lights. They are reminders of both impermanence and continuity, of the countless generations of stars that have lived and died, shaping the cosmos long before our own sun came into being. Light as a time machine. For observing stars, light is more than illumination. It is the universe's storyteller. Every photon carries information, traveling vast distances to reach our instruments and eyes, often over millions or billions of years. When we observe a star, we are seeing it not as it is now, but as it was when that light began its journey. This cosmic time travel allows us to witness the birth and death of stars long gone, to measure events in galaxies that no longer exist in their current form. Supernovae, stellar flares, and the slow dimming of ancient suns are all preserved in this journey of light. The idea is both humbling and soothing. It reminds us that our perception of the universe is limited by distance and time, yet every observation is an act of discovery, a quiet communion with events far beyond our reach. In this way, the night sky becomes a meditation on patience, perspective, and the gentle unfolding of cosmic history, a reminder that we live within a vast and enduring story. Variable stars that change in brightness. Some stars are not steady in their light. They pulse, flicker, or shimmer over time. Variable stars, changing in brightness due to intrinsic or extrinsic factors, add rhythm to the cosmic night. These fluctuations can be subtle or dramatic, some predictable and others mysterious, each revealing intricate details about stellar interiors and evolution. Cepheid variables, for instance, expand and contract with regularity, their pulsations serving as cosmic yardsticks to measure distances across the universe. Other stars may dim unpredictably, hinting at complex processes, companion interactions, or even surrounding dust. Observing variable stars is a gentle reminder that change is natural, even among objects that seem eternal. Their variations create a celestial heartbeat, echoing the universe's constant motion and transformation. For those who pause to watch, variable stars offer a quiet lesson that beauty is not always constant, and that the universe thrives in cycles, pulses, and shifts. In their changing light, we perceive both impermanence and grace. Cepheid stars as cosmic rulers. Cepheid variables are more than just fluctuating stars. They are rulers of the cosmos. By measuring the period of a cepheid's pulsation, astronomers can determine its intrinsic brightness, and therefore its distance from Earth. This discovery revolutionized our understanding of galactic scales and the universe's expansion. These stars serve as markers in the vast darkness, linking human observation to cosmic dimensions. Each pulse is a steady, predictable beat, offering clarity in a universe of immense complexity. The calm regularity of cepheids reminds us that even amidst billions of stars, patterns emerge, allowing us to measure and comprehend. Their discovery highlights the marriage of curiosity and patience. Observers across centuries noted the cycles of these stars, and only through careful study did their cosmic significance unfold. Cepheids are a gentle reminder that even in the boundless night, structure and order provide guidance and perspective. Through their rhythm, the universe communicates subtly, inviting us to listen, measure, and marvel at the intricate choreography of stars. Supergiant stars that outshine entire galaxies. At first glance, a supergiant star seems like an ordinary point of light, yet its brilliance can eclipse entire galaxies. These titanic suns burn with unimaginable energy, sometimes tens of thousands of times brighter than the sun, and they live fast, exhausting their fuel in mere millions of years. Their sheer scale and luminosity create a sense of cosmic awe. Some supergiants, like Betelgeuse and Orion, are visible to the naked eye, despite being hundreds of light years away, glowing with a warm, ruddy light that hints at their immense energy output. Others, far more distant, require powerful telescopes to perceive their glow, yet their presence shapes galaxies, driving winds and dispersing elements across space. Supergiants play a vital role in cosmic evolution. When they die, often in spectacular supernovae, they seed the interstellar medium with elements crucial for future stars, planets, and even life itself. Their brief, intense lives are a reminder of the delicate balance between power and impermanence. To observe a supergiant is to witness the universe's extremes, light, heat, and gravity, converging in a star whose existence is both fleeting and profoundly influential. The smallest stars ever found. In contrast to supergiants, the smallest stars are quiet, unassuming, yet remarkably enduring. Red dwarfs and other low-mass stars burn their fuel slowly, often for trillions of years, far outliving more massive counterparts. They emit gentle light, usually dim to the naked eye, but in their patience lies a profound lesson about longevity and resilience. These diminutive stars are the most common in our galaxy, forming the majority of stellar populations. Their small size belies their importance. Red dwarfs are long-lived laboratories for planetary systems, potentially hosting worlds for trillions of years, long beyond the lifespan of more massive stars. Observing these tiny suns encourages reflection on subtlety and endurance. They remind us that power is not always the measure of influence. Quiet persistence can outlast grandeur. Their steady glow, nearly constant over unimaginable time, offers a meditative perspective on the slow, deliberate rhythms of the universe. In a sky dominated by bright, flashy stars, the smallest stars quietly illuminate the vast stretches of space, proving that even subtle light has significance in the cosmic story. Brown dwarfs, the failed stars. Some celestial objects exist in between planets and stars. Brown dwarfs, often called failed stars, they lack the mass to sustain hydrogen fusion at their cores. Though dim and faint, brown dwarfs are still warm and sometimes glow in infrared light, revealing themselves to sensitive telescopes. These elusive objects challenge our perception of what it means to be a star. They are reminders that nature operates on a continuum, not in strict categories. Brown dwarfs occupy a liminal space, more than a planet, less than a sun. Yet they influence their surroundings, shaping the evolution of nearby gas, dust, and even planetary systems. In contemplating brown dwarfs, there is a quiet fascination with the universe's diversity. Not every object must be grand or luminous to matter. Even these subdued wanderers carry clues about star formation, planetary evolution, and the richness of cosmic possibilities. Brown dwarfs teach patience, subtle observation, and the value of looking beyond the obvious. In the quiet glow of these failed stars, the universe whispers of complexity hidden in plain sight. White dwarfs, the quiet remnants of suns. Stars like our sun eventually exhaust their fuel, shedding outer layers and leaving behind white dwarfs, dense fading cores that shine with residual heat. Though small and faint compared to their former brilliance, white dwarfs are enduring reminders of stellar life cycles and cosmic continuity. A white dwarf is extraordinarily dense. A teaspoonful would weigh tons on Earth. Its light, often white or bluish, persists for billions of years, gradually cooling and fading toward eventual darkness. In their quiet glow, these remnants offer a meditative view of the universe's cycles: birth, brilliance, decline, and the gentle persistence of matter over time. White dwarfs also reveal cosmic history. Their composition, temperature, and age can be measured, offering insight into the evolution of their progenitor stars and surrounding galactic environments. Observing them is akin to studying a fossil, a lingering trace of stellar energy preserved across eons. In their calm endurance, white dwarfs invite reflection on the passage of time, the impermanence of brilliance, and the quiet persistence that remains when the fire of youth has faded. Black dwarfs, the theoretical end of all stars. If we extend the timeline far beyond the present universe, white dwarfs eventually cool into black dwarfs, cold, dark remnants, no longer emitting detectable light. Though purely theoretical today, black dwarfs represent the ultimate fate of most stars, a quiet, almost invisible conclusion to billions of years of fusion. Black dwarfs embody stillness and silence. They are objects that once burned with radiant energy, but now exist in peaceful dormancy, witnesses to the long history of the universe. Contemplating them is to consider the distant future, when the cosmos itself may approach a state of deep quiet and equilibrium. These theoretical stars also provoke reflection on impermanence and endurance. Even objects as grand as stars will ultimately settle into calm darkness, reminding us of the universe's patient march of time. Though unseen, black dwarfs inspire awe for the vast timescales of cosmic evolution. They teach that all things, no matter how brilliant, eventually return to stillness, and that quiet persistence across eons is a form of cosmic beauty in itself. How stars shape the structure of galaxies. At first glance, galaxies may seem like smooth, ethereal swirls of light, but stars are the architects of their form. Their gravity, motion, and life cycles sculpt spiral arms, dense cores, and halo populations, creating patterns that span tens of thousands of light years. Young, bright stars trace the spiral arms of galaxies, illuminating dust and gas as they burn fiercely and live briefly. Their supernovae scatter elements into space, enriching the interstellar medium and providing the raw materials for new generations of stars and planets. Meanwhile, older, dimmer stars populate the bulge and halo, anchoring the galaxy's structure with their gravitational pull. Through these interactions, stars both build and maintain galactic architecture. The balance between gravity, stellar winds, and explosive deaths ensures that galaxies remain dynamic yet ordered, constantly evolving over cosmic time. Observing how stars influence galactic form invites reflection on interconnection. No star exists in isolation. Each contributes to a larger pattern, weaving together the luminous tapestry of the universe. In their collective dance, we glimpse the profound harmony underlying cosmic complexity. The role of stars in cosmic evolution. Stars are not static points of light. They are agents of change, catalysts in the grand story of the cosmos. Their formation, evolution, and death drive chemical enrichment, galactic dynamics, and the very conditions necessary for planets and life. From the earliest massive population 3 stars to the quiet persistence of red dwarfs, each generation alters the universe. Supernovae scatter heavy elements, white dwarfs fade, black holes anchor galactic centers, and stellar radiation shapes nebulae and star-forming regions. These processes occur over billions of years, yet together they define the evolution of galaxies and the cosmos itself. Stars are both transient and eternal. Individually, they exist for millions or billions of years. Collectively, they maintain the universe's rhythm, recycling matter and energy through cycles of birth, death, and rebirth. Contemplating this gives a soothing perspective. Stars are not merely lights in the sky. They are the quiet engines of cosmic history, orchestrating evolution on scales that surpass human comprehension, yet touching every atom we encounter. The endless recycling of stellar material. Within the universe, nothing is truly lost. Stars forge elements, explode as supernovae, and return their material to interstellar space. This cosmic recycling ensures that matter is continuously repurposed, giving rise to new stars, planets, and even life. Hydrogen and helium, the simplest elements, serve as the foundation. Heavier elements, carbon, oxygen, iron, and beyond, are created in stellar cores and scattered through space in violent but beautiful events. The dust and gas left behind form nebulae, where new stars ignite, continuing the cycle. This endless recycling is both practical and poetic. Matter passes through countless forms over billions of years, each generation of stars contributing to the universe's richness. It is a reminder of continuity, that energy and matter endure, changing shape but never disappearing. The next time you gaze at the stars, imagine them as part of an eternal symphony, each birth and death, a note in the ongoing melody of creation. In this, the universe offers both wonder and gentle reassurance. Stars as the universe's element factories. Think about the atoms inside your body. Carbon, oxygen, nitrogen, all were once formed in the cores of stars. Each element heavier than hydrogen and helium is a product of nuclear fusion, a process that converts mass into energy, producing the building blocks of planets, life, and even future stars. Stars are essentially cosmic forges, transforming simple material into complex structures over millions of years. The most massive stars create the heaviest elements, scattering them across space in supernova explosions. These stellar factories ensure that the universe continually grows in chemical complexity, enabling worlds to form and life to emerge. This perspective lends a quiet humility. The atoms within us are ancient, recycled through countless generations of stars before becoming part of our bodies. In a sense, we are living records of the universe's alchemy, intimately connected to the very stars whose light we admire at night. Understanding stars as element factories deepens our appreciation for cosmic time and space. It is both scientific and poetic, a gentle meditation on how existence itself is intertwined with these distant luminous engines. Why we are made of stardust. Every atom in our bodies was forged in the hearts of stars. This is not metaphor, but fact. Our chemical composition is the legacy of billions of years of stellar evolution. When stars explode, they scatter these atoms across the cosmos, where they become part of new stars, planets, and eventually living beings. In this sense, we are stardust walking, thinking, and observing. Our existence is directly linked to the life cycles of distant suns, to processes that occurred long before Earth itself formed. The quiet poetry of this reality invites reflection. We are not separate from the universe. We are a continuation of its cycles made tangible through light, matter, and consciousness. Knowing that our very bodies are composed of elements born in stars instills a profound sense of connection to the cosmos. Each breath, each heartbeat is a reminder that we are part of a grander rhythm, a universe that creates, destroys, and recreates endlessly. This thought, gentle and expansive, brings a serene calm, a comforting awareness that we are woven from the very fabric of stars. And in observing the night sky, we are, in a sense, seeing pieces of ourselves. The beauty of starfields in the night sky. At first glance, a starfield may seem like random points of light scattered across a dark canvas. Yet, when we look closely, patterns emerge, constellations take shape, and a profound sense of order is revealed amidst apparent chaos. Each star, from the faintest speck to the brightest beacon, contributes to a tapestry that stretches across space and time. In truly dark skies, far from city lights, the Milky Way appears as a delicate river of light, a gentle reminder of the galaxy we call home. Starfields and neighboring galaxies, glimpsed through powerful telescopes, show countless suns dancing in distant spirals and ellipses, each carrying its own story. Observing these starfields encourages a quiet, meditative appreciation. The sheer number of stars, billions in our galaxy alone, evokes humility and wonder, reminding us of our small place in the vast cosmos. Yet, there is comfort in this immensity, a sense that we are part of something enduring, infinite, and profoundly beautiful. Starfields invite stillness. To gaze at them is to step into a rhythm older than time, letting the mind wander among lights that have traveled for millennia to meet our eyes. Stars that form nebulae. After death, think about a star at the end of its life, shedding layers of gas and dust in a graceful yet violent finale. These ejected materials form nebulae, ethereal clouds of glowing matter that drift through space, often illuminated by the remaining stellar core or neighboring stars. Planetary nebulae, for instance, exhibit intricate shapes and vivid colors, a cosmic artwork painted by the interplay of light, gravity, and magnetic fields. Supernova remnants, larger and more chaotic, carry elements forged deep within the star's core, spreading the seeds for future generations of stars and planets. In their death, stars give back to the universe, creating structures that are both visually stunning and scientifically invaluable. Nebulae are cradles for new stars, a reminder that endings are intertwined with beginnings, and that life, in all forms, arises from transformation. Observing nebulae invites calm contemplation. Their slow expansion and luminous glow speak of patience and renewal, of cycles that span millions of years, and of beauty emerging even from destruction. The future of stars in a dying universe. If we extend our gaze to the far future, stars will not shine forever. The universe will continue its quiet expansion, and stellar birth will gradually slow as gas reserves are depleted. Massive stars will burn out, white dwarfs will cool, and red dwarfs, the universe's long-lived embers, will eventually fade. This distant future is both humbling and strangely comforting. It shows that all things have a life cycle, even the most powerful lights in the cosmos. Yet the gradual fading of stars is not violent or abrupt. It is a slow, almost poetic dimming, a transition into stillness that mirrors the calm inevitability of cosmic time. Thinking about a universe with fewer and fainter stars can inspire reflection on impermanence and change. Even as brightness fades, the universe retains its structure, carrying the memory of past stars in lingering light, residual heat, and the elements scattered across space. This long-term vision offers a serene perspective. The cosmos moves at its own rhythm, beyond human urgency, yet endlessly unfolding in quiet complexity. The last stars that will shine in the darkness. Among all stars, the final survivors will be the low-mass red dwarfs, patiently burning for trillions of years. In a universe where most light has long faded, these faint embers will continue to shine, the ultimate witnesses to cosmic history. Their enduring glow is a meditation on longevity and subtlety. While they cannot rival the brilliance of supergiants, their persistence is profound. They remind us that endurance, not intensity, can carry significance across unimaginable spans of time. Eventually, even these final stars will exhaust their fuel, leaving behind cold, dark remnants. But in their trillions of years of shining, they will have illuminated the cosmos in quiet, persistent grace, outlasting civilizations, galaxies, and perhaps even entire cosmic epochs. The last stars teach patience and awe. They embody the universe's gentle persistence, showing that even in vast darkness, light can endure, quietly carrying the memory of all that came before.